Well, who can forget that awesome display of Northern Lights not long ago, right?
Amazing.
This is kind of part two then, Jacob. Last week you talked about the science behind it, but photography is really everything too, isn't it?
It is, and I'm not a professional photographer, somewhat of an amateur Northern Lights photographer, but I've been out enough times and captured some spectacular photos to provide some information to you as you're going out and capturing those aurora borealis displays. And this is me setting up my camera as the sun was setting for a Northern Lights display. But the keys here and cell phone cameras have gotten so good over the years that you might not need a nice camera setup like this that I have. But with these DSLR or mirrorless cameras, you can get some more in focus and high definition photos using long exposure photography with low aperture, and a wider lens will get you a bigger expanse of the landscape, a much larger view of the Northern Lights display. So the exposure triangle is known in the world of photography. We have our aperture size, these f-stops are what they call it, letting in a lot more light versus letting in a lot less light depending on the f-stop number. The ISO is the light sensitivity. When we increase that number, that also lets in more light to the camera. And then the shutter speed, that's the big key with Northern Lights photography. You want to increase this to a couple of seconds. So it's long exposure photography to let in more light, because sometimes these displays can be only faint to the naked eye, and we need to allow our cameras to capture as much light as possible. Try to focus on the stars. That's one of the most difficult aspects. You don't really have a great focus point. And using a tripod and a remote or timer will get you the best results, so that when you're pressing the shutter button, that doesn't generate any camera shake. Here's one of my favorite aurora photos that I took earlier this year in February near Cole Harbor, and this was the settings that I used with this photo. 16mm lens, so it's pretty wide angle. You get a pretty good view of the landscape. f1.4, that's the very small f-stop, letting in a lot of light to the camera. And then the 8 seconds of the exposure time is really the key there to allow the photo, the camera to capture as much light as possible with that aurora display across the night sky. If it's a weak aurora, it might be faint to the naked eye, so as you're driving along, trying to figure out where the best place is to stop, you might only see a faint green or even gray hue. But be safe on those dark and rural roads. The moon phase can impact your photography of the aurora. This was when the moon was a lot brighter and kind of impacted this photo that I took. So a new moon will be the best for aurora photography. If you can position yourself along a lake or a river, that'll be a really nice reflection, as long as the water isn't moving that fast, like I took in that photo near Turtle Lake. And if you can put some foreground objects, this isn't the best example, but this was one that I took in steel. Some people have gotten really nice aurora photography photos in front of churches or farm equipment, something along those lines. And if you put your camera in time-lapse mode, you can get a cool picture of how the Northern Lights dance across the night sky. But there's all sorts of types and shape classifications of the Northern Lights. As you're photographing them, you might be wondering what you're seeing. Well, some of these more faint ones, these are called arcs and bands. That uniform arc is the most stable form. The other forms can undergo dramatic variations throughout the night. And the shapes are determined by our magnetic field, and that's how the aurora forms, all those particles from the sun impacting and interacting with our magnetic field. And these pillars or curtains are some of the more common aurora shapes that you see on stronger Northern Lights viewing opportunities. See those dancing across the sky. These more diffuse patterns are just that green glow, and the one that is the most coveted aurora photo is the coronas, when you're looking straight up in the night sky and you can see that aurora almost like a dome shape coming down on you. I was lucky to photograph some of those coronas a couple of months ago near Cole Harbor. Another form of the aurora that is very new to research is called STEVE. It stands for Strong Thermal Emission Velocity Enhancement. Lots of words there, but it was a citizen scientist discovered. We don't know a whole lot about it. It's this green picket fence look that you might see when we're seeing a really strong aurora display under that purple hue. So a lot of science to go into with this space weather and aurora forecasting. So going back to that April 23rd aurora display, we had a lot of videos and images come in of that typical slowly shimmering curtains effect of the aurora, those pillars that you can see across the night sky. But we also had these really interesting videos sent in of intense flickering or pulsing of the aurora. And what causes that? Let's go back in time. Some scientists observed this in 1966. They were recording the flickering on a sensitive TV, And they finally figured out that the aurora was flickering instead of just a problem with your old-time TV sets that sometimes flicker. Now, a more recent study in 2017 in Alaska that used the latest high-speed camera technology and observed the flickering of the aurora as fast as 1/80th of a second. And it all starts, going back to the science of the aurora, with these protons and electrons that are emitted from the sun. Remember, with those solar flares and coronal mass ejections, they collide with molecules in our upper atmosphere where they create tiny flashes of light with these collisions with oxygen and nitrogen molecules. And NASA has a couple of really interesting space probes. And what they are monitoring is our magnetic field. And the aurora has moved in harmony with the vibrating magnetic field that protects the Earth. But some of these electrons and protons come into our atmosphere, and that creates for that spectacular aurora display. So it's similar to waves at the beach, where the aurora brightens when that wave of electrons slams into the upper atmosphere of Earth and dims when it ricochets off. So here's a very cool animation from NASA. Those solar particles and energy that come in from the sun, they disturb our Earth's magnetic field, and it stretches that magnetic field behind the Earth backwards, kind of like a rubber band. As that magnetic field snaps back, that you're going to see in a couple of seconds here, all of those electrons and particles slam into our upper atmosphere, and that creates for that aurora display. There is that snapback of the magnetic field, and we can see that very colorful aurora near the North and South Pole. So a little bit of science behind the aurora, part 2 there, as well as the things that you're photographing in the night sky with those beautiful pillars, curtains, arcs, and everything else. Hopefully you have some more tips now to go out and send us some awesome photos.
Now be honest, not every picture that you take turns out, right?
There's some duds, like we're going out on the middle of rural road in Baldwin, and I'm looking and there's nothing there. So
okay, one quick question for you.
Yes.
A lot of people wonder, I wondered myself too, that what your camera captures isn't necessarily what you see.
Correct.
You have to let your eyes adjust. I've heard maybe 30 minutes to 45 minutes.
Exactly.
People use red lights and stuff to kind of get your eyes to adjust. So the camera can see what you can't, because your eyes have to take a long time if you see a faint display.
Exactly, and obviously some photos are edited. I try to edit my photos as less as possible.
Right.
But obviously with the photography that I do, you have long exposure, so it's a lot of seconds bringing in that light to the camera.
Just
Great
fascinating.
tips.
Yeah.
Thanks, Jacob.
Thank
You're
you.
welcome.